Hi everyone, this is Miss Barber with Lesson 5.8 in Algebra 2, Curve Fitting with Quadratic Models. So in Chapter 2, we did curve fitting with linear models, and we used our calculators to help us determine our values for m and b and our r squared, or our r value. We're going to be doing the same thing today, but now we're going to be doing it for quadratic models. So in a quadratic, the second differences are going to be constant. So in linear, your first differences, or when you subtract your y's, they're going to be constant given that your x's are evenly spaced. Given that our x's are evenly spaced in a quadratic, our second differences are going to be constant or the same. So we'll see what that looks like here. So step one, you're always going to find the first difference. That means that you're going to do right minus left. So you're going to do 12 minus 6, or how do you get from 6 to 12? Well, that's going to be 6. 12 minus 6 is 6. 20 minus 12 is going to be 8. 30 minus 20 is going to be 10. And 42 minus 30 is going to be 12. So right minus left, we're finding the change in our y's. And this is going to be our first difference. So we did it once. Notice our numbers are not the same. So we're going to do it again. This model is not linear. They're not the same. So let's do it another time. 8 minus 6 is 2. 10 minus 8 is 2. 12 minus 10 is 2. Now all three of my numbers are the same. So my second differences are constant. So is this set a quadratic function? Yes, it is. My second differences are constant. If they aren't, then it's not a quadratic. In Chapter 6, we'll learn we can do this more times to find other types of functions, but for this chapter, if the second differences aren't constant, you can just say no and move on. So here's my second data set. Again, just triple check that your x's are evenly spaced out, and they are. They're going up by 1 each time. Now to find my y's, my first difference, I'm going to do right minus left. 1 minus 0 is 1. 2 minus 1 is 1. 9 minus 2 is 7. 28 minus 9 is 19. So my first differences are not constant. Let's try my second differences. 1 minus 1 is 0. 7 minus 1 is 6. 19 minus 7 is 12. Are my second differences constant? Nope, those are not the same. So is this a quadratic function? No, it's not. If you did the third difference, you might find that they are the same. That means it's a different type of function called a cubic function. We'll talk way more about next chapter in Chapter 6. So don't worry about that for today. So example 1, I have lots of different examples here, 4 different kind. Again, just triple check in every single one that your x's are evenly spaced. In number 1, they're going up by 1s. In number 2, they're also going up by 1s. In number 3, they're going down by 2s, but they're still evenly spaced. And in number 4, they're going up by 2, so they're evenly spaced. So again, for each, we're going to find the first difference by doing right minus left. So 1 minus 16 for the first one is negative 15. 0 minus 1 is negative 1. 1 minus 0 is 1. 16 minus 1 is 15. Those are not the same, so we're going to do it again. Negative 1 minus negative 15 is positive 14. 1 minus negative 1 is 2. 15 minus 1 is 14. These are not the same, so this is not a quadratic. Let's do one more together. Number 2. 3 minus 1 is 2. 7 minus 3 is 4. 13 minus 7 is 6. 21 minus 13 is 8. Those are not the same, so it's not linear. Let's do it again. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So my second differences are constant. So yes, this will be a quadratic function. So you can pause the video and try numbers 3 and 4 on your own. You should get no for both of them. So just like linear functions, we can find a line of best fit using our calculator. So for example, if we have the points 0, 1, negative 1, 1, 3, and 2, 9, we're going to put this in our calculator in our L1 and L2. So in your L1 in your calculator, and I'll show you where that is in a second, you're going to put your x values in the order they gave you. So 0, 1, and 2. In your L2, you're going to put your y's. So -1, 3, and 9. Make sure that you keep them paired up as they are. So 0 goes with -1, 1 goes with 3, 2 goes with 9. So here's the way that you're going to put it in. So once you put your L1 and your L2 in your calculator, you're going to press Stat, arrow over to Edit, put your X in L1, Y in L2, then you're going to go back, press Stat, arrow over to Calc, and choose number 5, Quadratic Regression, because we're doing quadratic. Now on my free graphing calculator, it won't let me do that, but I can show you a little bit of how that works. So here on my graphing calculator, you're going to press Stats, so it's on the third row, third over underneath the Delete button. You'll see Edit pops up. So in Edit is where I now have my L1, L2. If you have things in your L1 or L2, you want to go arrow up over L1 and then you just press Clear and Enter. Same thing, you could arrow above L2, press Clear and Enter, and that'll clear them out. Don't press Delete though. You don't want to delete the columns, you just want to clear them. So in my X's, I'm going to press 0, Enter, 1, Enter, and 2, Enter. And then in my L2, I'm going to do -1, 3, and 9. So now I have what I wanted in both my L1 and L2, my X and Y. You're going to go back and press Stat, and now you're going to arrow 1 over to Calc. I can't do this because it's I don't have the paid version of this calculator. Hopefully you're using it in school, so you can use our school calculators, but you would scroll down to number 4, sorry, it's 4 on this calculator, Quadratic Regression. Press Enter as many times until you get your answer. So that's how you would do it on a TI. There's also some free ones online. So here's a free one online where you can do it if you're at home. So you're going to fill in your X1 just like we did, or your X with what we put in our L1. So I'm going to put 0, 1, and 2 here for my X's. And for my Y's, I'm going to put in -1. Hopefully I can find the negative button. -1, 3, and 9. And then remember, we want a quadratic regression. So, I set this up for a linear regression. That is my bad. Hopefully I can go back. And I'll give you this website. We want quadratic regression down here. So, I need to clear out these tables. I apologize. We're going to do this again. So 0, 1, 2 for my X's. And then my Y's are going to be -1, 2, or 3, sorry, and 9. And then if you press execute, hopefully it works. So it shows you here that the y equals a plus bx plus c here. That's the basic format. And here they told you your correlation coefficient, your R is 1. So this is a perfect fit. This is exactly what this quadratic function represents. My A is -1, my B is 3, and my C is 1. So let's go ahead and put that back in my notes. So my A is 1, my B is 3, and my C is -1. So your A is in front of x squared. So usually we don't write 1s in front of x squared. So it's going to be x squared. Your B goes in front of x. So plus 3x minus 1. So that's how you find the line or the quadratic function of best fit here for these types of problems. So you would do the exact same thing for number 2. Again, either using a TI-84, using the green instructions, or you can go to that website. I'll make sure to link it in the folder. So here is an application problem where they gave me the diameter of a pool and then they told me the cost for each diameter, and they want us to use the model to estimate the cost when my diameter is 8 feet. So I need to get a equation that I'm then going to substitute 8 into. So I'm going to go back to my website that I'm using today to help me with this. I'm going to clear out what I started with, and I'm going to put in my new x values. So my new x values are 4, 5, 6, and 7. And my y's are 1995, 2025, $25 even, so I'm just going to put 25, and then lastly $34.95. And again, I'm just going to press execute. And it's giving me a correlation coefficient that says it's pretty darn close to what it should be. And it's giving me an A, B, and C value that I can then use to write my equation. Once I write my equation, I'm going to put 8 in for that value. So you're going to set it up. You're going to put your 8 in for that value, and you're going to solve when you substitute 8 in for your x in your equation. So that's it for lesson 5.8 in Algebra 2, Quadratic Regression. Hopefully you have some sort of TI calculator, because it's quite easy to do, and you should know how to do it when we do quadratic regressions, because we're going to be doing it again in Chapter 6 for different other